Hey guys, today I will be speaking about bowling and how speed, velocity, acceleration, balance and unbalanced forces, Newton's law, gravity, and types of friction apply to it. In the upcoming video clip, I will show you how speed, velocity, and acceleration are applied to bowling. In this video, the ball is being thrown at a high speed, and as it moves down the lane, it loses speed due to friction. As the ball collides with the pins, the force being exerted into the pins is the same amount being exerted into the ball by the pins. The velocity of the ball is 6.09 meters per second. In order to find the velocity, you have to find the distance of the lane, which is about 18.28 meters. Then you divide the distance by the amount of time it took for the ball to get across the lanes, which is about 3 seconds. And you get 6.09 meters per second as your velocity. In order to find the force of the ball, you multiply the mass and acceleration, and you get 88.9 newtons. When the ball is thrown, it has an acceleration of 14 miles per hour. To solve for the acceleration, you divide the force by the velocity, and you get 14 miles per hour. Forces equal in size but opposite in direction are known as balanced forces. In bowling, when two objects, such as pins, that are equal in size, they rely on an unbalanced force, such as a rolling bowling ball, to knock them down.
Newton's first law of motion states that every object will continue in a state of rest or with constant speed in a straight line unless acted upon by an external force. This law of motion applies to bowling because the pin will stay at rest unless another force was to act upon it. Also, the bowling ball will remain in motion unless acted upon by an external force. Newton's second law of motion states when a net force acts on an object, the object accelerates in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass. This applies to bowling because if a bowling ball had more mass and less net force, then it would take more force in order to achieve the same acceleration that it would have if it had less mass and more net force. So, the more net force that the ball has, the more its acceleration increases. But the more mass the ball has, the more its acceleration decreases. Newton's third law states that whenever one object exerts a force on the second object exerts an equal and opposite force on the first. This applies to bowling because when the ball is thrown at the pins and makes contact, the amount of force the ball exerts into one pin will be the same that the pin exerts on the bowling ball. Have you ever noticed how when you throw the ball down the lane, it doesn't just float off into the sky? The force that keeps the ball from doing this is known as gravity. The force that counters gravity is known as normal force. As shown on the free diagram, many forces are acting upon the ball. As applied force is making the ball move and the friction is slowing it down, gravity is pulling the ball towards the ground. As a ball is thrown down the lane, it will slow down over the course of time. The main cause of this is friction. The amount of friction can be affected by the amount of oil on the lane. The more oil that is applied on the lane, the less friction that will occur. As the bowling ball moves down the lane, the friction will slow down the ball. So, the less friction that occurs on the lane, the faster the ball will move. This is known as rolling friction and kinetic friction. This is how speed, velocity, acceleration, balanced and unbalanced forces, Newton's laws, gravity, and types of friction apply to bowling.